In the small signal equivalent for a circuit containing a forward bias diode, the diode is replaced by a small signal resistance, which is inversely proportional to the bias current. And is this true or false? Well, if we look at the small signal diode model, and this can be found in the notes linked with a like button, we have this diagram here with a small signal equivalent circuit. We have small signal diode resistance here. GD is equal to our ID over VD at the bias point. So our RD is going to be 1 over our GD, which is equal to VT over our ID. And that's pretty important, we'll come back to it though. It is often convenient to analyze a non-linear circuit for small variations around a bias point. And this bias point we call the Q point. We can use linear circuit analysis methods like voltage division. You can see that right here. To do this, we must find our RD. This is the small signal resistance of our diode. Then we can draw the small signal equivalent circuit and analyze it using standard linear circuit analysis methods. And then if we wanted more of an example about this, we have this in the notes, and we also have a video on it as well that goes through this and kind of demonstrates how this would work with our current flowing through here, and then getting the resistance and the voltage here. But going back to here, we just want the notes for this. So when we look at the problem, it says in the small signal equivalent for a circuit. So we're going to be looking at the small signal. That is already a check right there. Containing a forward biased diode. Now we have our forward biased diode. We know that whenever our arrow is pointing this way, the same way as our current flow, it's going to be forward bias, so that's okay too. The diode is replaced by its small signal resistance. Well, we have a small signal resistance right here of our diode, which is our RD. So this is true. We know this to be our R subscript D, and it's inversely proportional to the bias current. So now this part is important. So we have inversely proportional bias current. Well, we know our RD is equal to our VT over our ID. And so because our ID right here is on the bottom, that means it is inversely proportional. If it was on the top, it would be proportional. So like VT is proportional to our RD, but I of D is inversely proportional. So the answer for this one is going to be true. Since yes, in the small signal equivalent for a circuit containing a forward bias diode, the diode is replaced by its small signal resistance, which is what we have here, and it's inversely proportional to the bias current.